Book E2, Chapter 1, Towards the Modern Atomic Model. There are 3 subchapters in Chapter 1. We will first study the Rutherford atomic model, and then go through the history of photoelectric effect, and lastly, to see how Einstein explained the observations in photoelectric effect by using particle theory of light. So here we go, back to chapter 1.1. It was mentioned in book 5, page 38, that J.J. Thomson proposed a plum pudding model for atoms, and later on, Rutherford does not satisfy with that model, and so he carried out his scattering experiment. The result of the gold foil scattering experiment suggested that the positive charges concentrate in a tiny volume, so-called nucleus nowadays, and the electrons are actually attracted by the electric force, Coulomb force, between the electrons and the nucleus. So the Coulomb force is given by 1/4 pi epsilon naught, the product of the kills divided by the distance square. In this way, it provides the necessary centripetal force, expressed as mv squared over r or m omega squared r. In this way, we may then carry out a little bit of calculation and then find the frequency of the rotation to be something like this. The Rutherford model appeared just fine, but there are things that it cannot explain, so-called difficulties. First, according to the theory of electromagnetism, when the electrons are in constant circular motion, they are having an acceleration. This centripetal acceleration should emit electromagnetic waves, but in this way, the electron will lose its energy, and the atom may collapse. Secondly, in Rutherford model, the orbital radius, velocity, and frequency of an electron has no limitation. They may take any random values. However, atoms of gases are found to emit electromagnetic waves of certain characteristic frequencies only. So we got to find some way to limit the value of radius, frequency, and velocity as well of electron, so that it does not emit electromagnetic waves while it is in circular motion. And there was then Bohr who solved the problem. He proposed a new atomic model afterwards. Now see if you can, just like in example 1, find out the frequency of the circular motion when an electron is orbiting the nucleus. Atoms are like black box. We use this experiment to explain. In this case, there are 2 boxes where there are different arrangement of straws. In one, the straws are concentrated at the center, and in another, the straws are almost evenly spread. We then now cover the boxes with a black card, and afterwards, we mix them up so that you cannot identify them. And our marbles are projected from one side into the box, and you can see how the marbles come out from the box. Just by observing the motion of the marbles, can you identify which box has the straws concentrated and which box has the straw evenly spread? In one case, you may see that the marble bounces back, and that must be come from the one with the straws concentrated at the center. While in this case, when the straws are almost evenly spread, then the marbles may be deflected to adjacent sides instead. Atoms are small, and there's no way to look into an atom. So the only way to study the structure of an atom is by using scattering experiment. Different particles are accelerated to bombard an atom, and some new particles are often found after the bombardments. And that's why the scientists are fond of building large particle accelerators to carry out particle collisions, and in such a way study the structure of an atom. Now try the checkpoint below.